Welcome to the SolidWorks course for SolidWorks Drawing Professional. What is the goal of this course? The goal of this course is to prepare students to pass SolidWorks Drawing Tools Advanced Professional exam, and also to equip students with advanced drawing techniques. Who is this course for? For intermediate user, advanced user, professional students, exam participants. So if you have some knowledge in drawing tools, you can skip first few lectures and then you can go to lectures where we cover some advanced techniques. Or if you don't have any knowledge in drawing tools, you're also in the right place because we're gonna start from the beginning. So anyone who wants to expand knowledge or prepare for exam, this is the right place for you. Requirements for this course: you must possess some basic knowledge of part modeling, assembly, creation, and if you don't have any experience in SolidWorks, you can take course SolidWorks CSWA preparation, because this course starts from the beginning, and then you can move to this course later. But there is no need for previous knowledge in drawing tools, so because we start from the beginning. So what will you learn in this course? We're gonna start from the beginning, how to create a sheet, how to insert views, and so on. So how to create different views and modify them, how to create a bill of material table and modify the table, and also some additional techniques. All supporting files in this course are made in SolidWorks 2016. So if you have SolidWorks 2016 or a newer version, you'll be able to open supporting files. If you have older version, you won't be able to open, maybe you will be able to open them, but you won't be able to modify them. So try to download some trial version, or you can create your own files and you'll be good to go. At any point of the course, if you have any question or if you find any mistake, you can post a question in Q&A section, or you can send me an email. And thank you for choosing this course, and I hope that you will enjoy. In this lecture, we're gonna show how to set up a drawing sheet. So launch your SolidWorks application, and here we have an icon New. Let's click on New. Now we have three options here: Part, Assembly, and Drawing. You can double click on Drawing or just click one time and then OK. Now we have to choose sheet format size. Here we have some standard sheet size: A0, A1, A2, A3, and A4. We can also click here on Browse, and now we can choose here our format size. Let's go with a landscape and OK. And now we have created drawing sheet. Here we're gonna insert our views, and here are some information that we can fill out about our drawings. This is the end of the lecture. In this lecture, we're gonna show how to create orthographic views. So we have opened this part, then you can download, and now we go to this icon, New, and here we have some arrow. Let's click on this arrow, and here we have option, Make drawing from part assembly. So let's click on this. Now we choose here drawing. Here we have to choose our sheet format. Let's go browse and let's go with a landscape and OK. And now if we want to insert our part on the drawing sheet, and if we want to create orthographic views, we have two options how we can do this. We can go here to View Layout, and here we have Model View. So let's click on Model View, and now we have this part, Open Documents part. So let's double click on it, and now we have some options here. We can create a front view, we can create top view, we can insert bottom view, right view, left view, isometric view, and here we have more views: dimetric, trimetric, and current model view. So let's insert front view. So just drag your mouse here, and now you can place your view here. And this is now your base view. Now if you drag your mouse up, automatically you have top view. So you can just click on it, and that's it. If you go right, you have right view. If you go left, you have left view. If you go down, you have bottom view. And if you go to side here, you have isometric view. And you can just click on it. And OK. And now if you click on the front view, base view, and try to drag it, you see that all views are connected. So the base view is the first view we inserted into drawing file. And other views are linked to our base view, except for the isometric view. If we move isometric view, we see only isometric view is moved. If we move right view, we see that we can't move right view up and down because it's linked to our base view. We have to move our base view. And those views that we have created are orthographic views. Those are standard views. Also, we have another option how we can create our views. But first, let's delete those views. We can click on this one, and now we can just press on the keyboard delete. And yes, and now only right view was deleted. But also, we can right click on our view and delete here. If you want to delete all, you can select all and press delete. Yes, all. Here we have view palette. Let's click on the view palette, and here you have parts that are opened. So we have open now only part document. And here down we have a different view of this part. So also we have front view. We can insert front view. And now we can create a top view, bottom view, and so on. Let's click escape. Let's go to view palette, and we can insert top view separately like this. And now we only have front view and top view. We also have isometric view, dimetric view, trimetric view, and current view. This is the view of the model in the part document file. So those are two ways how you can insert your views on the drawing sheet. In this lecture, we're going to look at the view properties and projected view. So we have base view or front view, and we have top view. And for instance, we want to add a right view of this front view. So you can just click on it, and here we have option projected view. If you click on this and you go right, you got a right view. And if you click again, projected view, if you go down, you have a bottom view, or if you go left, you have a left view, or you have isometric view. So let's make a left view and escape. If we click on this view, our top view, and if we go to projected view, then this is our base view, and we have a right view of this view. Or, for example, of this view. If we click on it, on the projected view, now we have a right view of this view. So this is our base view now. So in projected view, you can create right view, left view, top view, bottom view, and isometric view from the view that you choose to be base view. Let's delete this one. Let's delete this one. And this one. And now we have a base view, and we have a right view and left view. The second thing that we're going to show are view properties. So if we click on this view or base view, front view, we have here some properties. Let's go down, and here we have display style, and now we have hidden lines removed. We can go with shaded with edges, like this. We can also go shaded. We can go hidden lines visible. Now we see hidden lines. And we can go wireframe. And now if you notice, if we change on this view, display style, automatically display style is changed on those two views, left and right, because they are linked to the base view. Also, we can go to scale. Let's go to use custom scale, and here we have some custom scales. So let's go to 1 column 5. We can go to 1 column 1, or we can go here and user defined root. And now we can choose our own scale. For example, 1 column 2.5. Let's leave it to 1 column 2. Let's click OK. Now, as you saw, we have changed display style and scale of the front view, and automatically the right and left view were also changed. If you want to change only for right view scale and display style, just click on the right view. Let's go here. Let's go shaded with edges, and now only changes are applied to the right view. We can change scale, 1 column 1, and OK. And this is how you can change display style and scale of your views. In this lecture, we're gonna show how to put dimensions to our views and how to change units. Putting dimensions to the views is the same thing like putting dimensions in the sketch when creating a part. We go to annotation, and here we have option smart dimension. Let's click on it, and we do the same thing as in the sketch. If we want to make this dimension, we can click here, and we have 100. If we want to make this radius, we click here, and we have radius 30. And if instead of radius we want a diameter, we can go to here and diameter, like this. Let's go to radius. So we can make from here to here and here. And this is the same thing as creating a sketch. And now we are in millimeters. We can change our units to inches. Let's go here, down, we have millimeters, and let's go to inches. And now automatically all dimensions are changed to inches. So it doesn't matter if you use millimeters when creating a sketch and now you use inches. It's really up to you what unit system you're gonna use while creating drawing. So if we're gonna go to millimeters, just click here, millimeters. And now, for instance, we have this slot here, and this slot is symmetrical. And we want to make dimensions from the middle of this slot to this edge. But we don't have a line here. We have two options. We can go to sketch, we can choose center line, and we can draw a center line here, like this. And now we can go to smart dimension, click here, here, and make 40. This is one way. The other way, let's delete this. The other way is that we go to annotation and center line. So we can click this line and this line. And now we have a center line here. Okay, and now we can go to smart dimension and we can make dimension here. As well as with the radius. If we want to find where is the center of this radius here, we can go to annotation, center mark, click on this radius, and now we have this. Also, if you want to find the center line between those two lines, you can go to center line, click on this line, okay. And now, for example, you can put dimension from this to this. Depends what you need. Also, you can put angle here like this, 45. So dimension in drawing view is the same thing as putting dimensions in the sketch. Unit system doesn't depend on the unit system when creating a sketch. In this lecture, we're gonna look at tool model item. So in the previous lecture, we show how we can put dimensions to our drawing views using Smart Dimension. But also, when we have a lot of drawings and we have a lot of dimensions, we have one tool that calls model items that automatically puts most of the dimensions to our drawing. So let's go to annotation, and here we have model item. Let's click on the model item, and now we have some properties here. We have here source. We can choose entire model or selected feature. Let's go to entire model. Also, we have here a box. Import items into all views. You can check this and uncheck. Let's check. And down here, we have also eliminate duplicate. So all duplicates will be eliminated, or if you don't want that they will be eliminated, you can uncheck this. Let's check this and let's click OK. And now as you see, SolidWorks automatically put dimensions to our drawings. Now it's a little bit messy, and now you can make it more clear. You can also delete dimensions that you don't want, and you can add dimensions with smart dimensions that you want. For instance, this one. Now the question is, how SolidWorks know which dimension he has to put to our drawing views? Simply, when we were creating a sketch in the part file, and we were putting dimensions there, there is one option that it's called marked for drawing. And if this option, this icon is checked, then this dimension will be automatically inserted here on the drawing view when we use model item. So let's click on the model item, and here we have this icon marked for drawing. So we clicked on this, and then all dimensions that we choose in our sketch were automatically inserted to our drawing view. And if some dimensions in the sketch are not marked for drawing and we want them here, we can click then here, not marked for drawing, and this dimension will appear here. Let's show how this works. Let's click here on the one view and let's open part in position like this. Now let's go to our boss extrude, sketch 1, edit sketch. And now let's double click on the 50. For example, and here we have this icon, mark dimension to be imported into drawing view. If we check this one, also this is checked. Mark dimension to import into drawing views. Let's uncheck this one and let's click OK. And let's exit sketch. Let's save this. And let's go to our drawing. Let's delete this. Let's go undo. And let's go to model item. Entire model, let's leave everything as it is, and OK. And now we see that we don't have this dimension, this one. If you want this dimension, we can go to model item, and now click on this, not marked for drawing, and OK. And now as you see, this dimension And this dimension that was also not marked for drawing appear here. And this is how you can use model item to create dimensions on your drawing views. In this lecture, we're gonna look how model item works when we have assembly on our drawing. So we have this assembly, we have part 1, this one, we have part 2 and part 3. And we have a hole that goes through all, and we have this feature here on the top. So we want to put dimensions here using model item. So let's go to annotation and model item. So we have a few options here. We can go entire model, we can go selected feature, we can go selected component, and we can go only assembly. So let's start with entire model. So when we choose entire model, and this is on marked for drawing, then all dimensions that are in sketches marked for drawing will appear here. So let's click OK. Now we see that we have those dimensions that are in sketches of those 3 parts marked for drawing. If we want some additional dimensions, we can go to Smart Dimension and put those dimensions. Let's go back, let's go undo. So let's go to model items again, and let's choose now selected feature. So we're gonna choose this feature here on the top. So click on it, and now we see we have 2 dimensions here. We have 30 millimeters from this hole, and we have diameter of 10 millimeters. So let's exit. Let's try the third one, selected component. So let's click on this one, and let's choose this component, this pin. And now we got here the diameter of 20 millimeters. All those dimensions are created in Sketch and now are important into our drawing. Let's exit and let's show the fourth option that we have only assembly. What this means. So we have this assembly, and this assembly consists of 3 parts. Here we have a hole. This hole is not made in the part file. So this hole is not made in the part file 1, part file 2 and part file 3. This hole is created in the assembly file. When you create a feature in assembly file, you create assembly feature. And now if you choose here only assembly, then dimensions of those features that are created in assembly will appear here. So let's choose only assembly and OK. And now as you see, we got 10 millimeters. So when you're looking for assembly feature, the feature that is created in assembly, and you don't know if this feature is created in assembly or in the parts, you can use this model item and only assembly. And now we know that this hole is not created separately in part 1, part 2 and part 3. We know that it's created in the assembly file. And this is how you can use model items when you have assembly. In this lecture, we're gonna look at a tool hole callout. As you see, we have a part here with a hole. This hole is not created using extrude cut. This hole is created using hole wizard tool. If we want to put dimensions of this hole and this part, we can go to annotations and we can use smart dimension. So we can go here and we can dimension this diameter, we can dimension this diameter, we can dimension this depth, and we can dimension this depth. And this is how you can do it manually. But we have one tool that calls hole callout, and using this tool we can save some time. So let's go back. So let's go to annotation and let's go to hole callout, and let's click on this circle. And now we got radius and depth of this hole. Now as we see, we have diameter of 7 millimeters that goes 15 millimeters in depth, and then we have contour bore diameter 14.55 that goes 4.15 in depth. This is one way how you can use it. Let's delete this. As well, we can use model items. Let's go to annotation, model items. Here, let's choose entire model. And now if we leave everything as it is and click OK, dimensions of this hole don't appear. Let's go to model items again. And here under dimensions, we have one icon, hole callout. Let's check this on. Let's click OK. And now we got the same result as before using this hole callout. So when you have holes that are created with Hole Wizard, you can use hole callout and create dimensions for this hole. In this lecture, we're gonna explain and show what is view focus. Every view has its own view focus. View focus is focus area of this view. So if we go with your mouse over this view, you can see the highlighted square around this view. And this is view focus of this view. So for example, if we go to annotation, choose smart dimension, and we wanna put dimension, the angle between this line and this line. And this is possible because those two edges, those two lines are in the same view focus. But for example, if we go to sketch and draw a line outside of the view focus, now we see that this line, it's not in the view focus of this view. And now if we go to smart dimension and if we try to measure the angle between this edge and this line, this is not possible, simply because this line is not in the view focus of this view. Now the question is how we can make this line to be the part of this view focus. We have two options. The first option is that we click on this line, hold Ctrl and click X, then click on this view focus, hold Ctrl and press V. And now let's move this line here. And now we see our view focus has been extended. Let's make this line smaller, like this. And now this line is in view focus of this view. Now we can go to smart dimension. We can define an angle between those two lines, like this. And this is the first way how we can do this. Let's go back. And now we're gonna show the second way. So let's draw a line here. And now we wanna define an angle. We have to double click on the view focus. Double click here, go to sketch and choose center line. And now let's draw a center line here. And now we see that our view focus has been extended. And now we can simply click on this line, hold Ctrl and this line. Here we have add relations and we can make those two lines collinear, like this. And now let's go to annotation, smart dimension, and we can define an angle. Okay. And this is how you can create dimensions between entities that are not in the same view focus. In this lecture, we're going to show how we can edit our sheet. We have here some information about our sheet. For example, title, drawing number, size, scale, comments, name, date, material, and so on. And now, as we see, we can approach to this. We can change this. To approach to this, we have to right click here and go edit sheet format. And now automatically our views disappear. But now we can access and change those information. If we want to add title, just double click here. And we can add title part. If you designate this, you can change your style here. For example, going with something else, you can change the size. You can bold it and so on. And now let's click OK. If you want to change this drawing number, the same thing. Double click and we can put number 2, for example. And this is how you can change size, scale, weight, and so on. If you want to add some comment, you can't just double click here. You have to go to annotation, note. Choose note, click here, and then add a comment here. Comment and OK. The same thing is with name. You can't double click here. You have to go here and then put a name here. Name. You can make it smaller like this, and we can drag this inside the box. Okay. And this is how you can change and add information on your drawing sheet. If you want to go back, just right click on it and edit sheet. And now your views are back and changes are applied. In this lecture, we're going to show how to create a multiple sheets. If we look down here, we have only one sheet, this one. We can create and we can add here as many sheets as we want with different views. We can also right click on this sheet. We can delete this sheet. We can rename this sheet. So let's go down and let's click here, add sheet. And now we added a new sheet. We have the same format size as we used in the sheet 1. So we can go to view layout, model view, and we can now insert the same part or some different part, depends what we want. So let's insert this part, and now we can have here a different views. For example, isometric view. Let's put him here like this, and we can also right click, go edit sheet, and we can change the title. We can change this to part 2, for example, and edit sheet. Also, we can change the name. We can right click here and rename. Now let's call this sheet 2, like this. And this is how you can have in the same drawing file multiple sheets. And this is how you can add more sheets into the same drawing file. And on those sheets you can insert different views and different parts. In this lecture, we're gonna show how to use a measuring tool in drawings. Using measuring tool in drawings is the same as using measuring tool in part file or assembly file. So with measuring tool, you can measure the distance, radius, surface area, and so on. So simply we can go to evaluate tab, and here we have a measure. Let's click on the measure. And now, for example, we want to measure what is the radius here. So just simply click on this radius, and now we have, this is the 0.295 inches. And we can see the radius here as well. If we want to delete this, right click and clear sections or delete. Let's measure the distance between this line and this line. So we have few distances here. We have delta x, delta y, delta z, and we are looking for the normal distance. This is delta y, 2.362 inches. Let's clear this section, and we were now using inches. We can change the unit system by clicking here, units precision. And now, instead of length unit inches, we click here, and let's go to millimeters. And okay. And now, for example, if we want to measure the radius of this one, we can measure the radius here, and also we can measure radius on the isometric view. Let's click here, and we see the radius is 30 millimeters. So this is the same thing if we measure radius here, 30 millimeters. We can also measure the surface area, for example, of this triangle. So we have here area and perimeter, and here as well. We can also measure the distance on the isometric view from this line to this line. So we have distance 15 millimeters. Let's clear. As well, we can measure angle. For instance, we want to measure angle between this line and this line. And here we have an angle 135 degrees. And this is how you can use a measuring tool in drawings. In this lecture, we're going to show how we can save our sheets. So we have two sheets, sheet 1 and sheet 2. So let's go here to the save icon, and here we have this arrow. So let's click on it and save as. First, let's choose our destination. So we can go to desktop. We can add a name here as we want, name, and here we can choose our format. We can go with SolidWorks format, drawing. We can click here. We can save as TIF file, JPEG file, PDF file, and so on. So let's choose PDF, and let's go to desktop, and let's click save. And now SolidWorks asks us, select sheets to export. You can select both, or you can select one. Let's go with both, and let's click OK. And now, if we open our PDF file, name, we see that we have two sheets here, sheet 1 and sheet 2. So let's save our sheets as a SolidWorks file. So let's go save as. Let's go name. Let's go to desktop, drawing, file, and save. Now let's close this. And now if we open our drawing file name, we have him here. Now we have this sheet 1 and sheet 2. And this is how you can save your drawing sheets. In this lecture, we're gonna show a tool relative view. with this tool, we can define our own orthographic views. So first, let's insert our part. Let's go to View Layout, Model View. Let's choose Part 3.1, and let's go with Front View. So this is our front view, and it looks kind of awkward, weird, and this is not what we're looking for. So in this case, we have to define our new orthographic views, and we're going to use a tool, Relative View. So let's go to View Layout and to Relative View. If you don't have this tool here, you can go to Search command, type in Relative, and then choose Relative View. Or you can go to Insert, Drawing View, and Relative to Model. So let's click on this tool, and now we have to choose our orthographic front view, this one. And now we go directly to our part file. Here on the left side, we have to choose orientation. So we have first orientation and second orientation. For the first orientation, we can choose front, right, top, back, left, bottom. We're going to choose front. And for the second orientation, we can choose right, top, left, bottom, and we're going to choose bottom. Our front orientation will be this one, and our bottom will be this one. And now let's just click OK. So we are back. Let's go with mouse to our drawing, and we have created a new front view. And this is how you can create your own orthographic views. There is also a second way how we can define our orthographic views. Let's click on this view and let's open part. And now we want to choose another front view, and we want this one. So let's click on this one and let's go to View Orientation and Normal 2. Now let's go back to View Orientation, and here we have more options. Under more options, we have an icon here, Reset Standard Views. So when you have some awkward views, you can first start and try reset. If that doesn't work, you can define then new views by using Update Standard Views. So let's click on this one and let's choose Front View. This one, and now we have a question. Do you want to make this change? Yes. Let's exit. Let's go back to our sheet, and now we see that our view has been changed. So those are two ways how you can change your orthographic views. In this lecture, we're going to show how to create a section view. With section view, we can show a cross section of the object along a specific cut plane. So with section view, we can see what is inside a specific cross section. To use a cross section tool, let's go to View Layout, and here we have section view. Let's click on this tool. To create a section view, we need a cutting line. And here we have 4 cutting lines. The first one is vertical. Then we have horizontal. Then we have auxiliary. And then we have aligned. And we're going to cover all of those. But as well, we can create our own cutting lines. So first, let's go with vertical. And if we want to use a vertical line, we have to check Auto Start Section View. Let's click this, and now we see that we have a vertical cutting line. And now depends where we want a cross section, you can just click there. For example, we want to see the cross section here. So click here, and now you can drag this section view to left or to right. Let's go to left. We see that the name of this section is LL. We can change the name here on the left side. We have a label. Now let's type in A, like this. We can also flip direction to this side, as we see now, or to this side. Let's click OK. Let's go to section view again. And here we have horizontal. Let's try horizontal. So the same thing as with vertical, but now we have horizontal cutting line, and we can position our line where we want. So let's start here, and now we can go up and down. Let's go up like this, and we can change the name to B. And OK. Let's go to section view, and the next cutting line that we have is auxiliary. Let's click on this. And now first we have to choose our center. Let's start here. And now we have to define at which angle will be this cutting line. For instance, we can define something like this. And now we have our section view. We can also change the name to C. And OK. And the fourth one that we have is aligned. With align, first also let's choose a center point. Now we have to define an angle of this cutting line. We can go here, and we have to define an angle position of the second cutting line. We can define something like this. And now we have our section view. This is OO, we can change to DD. Now, if you click on the section AA, let's go to our properties. We can change here display style. The same thing as the views that we shown before. So we can go shaded with edges and so on. And we can change our scale. We can use sheet scale like this, or we can use custom scale. We can change to 1 column 5 like this. Let's go and let's change to 1 to 1. And OK. So those are all standard section views that we can create using standard cutting lines. But we can also create our own cutting lines. But before we do so, let's delete our section views here. Just press on it and delete. Yes. This one, and this one. So let's go again to section view, and let's choose horizontal. But now we're gonna turn off auto start section view. Let's turn off, and let's go with our line here at this point. Let's click here, and now we have some options here: arc offset, single offset, notch offset. So we can choose, for example, notch offset. Now you can see you have the picture how it looks like. So we can define the second point. Now you can see the second point here, and now we can go up and down, and we can choose our position where our cutting line will be. If we want to define some dimensions of this cutting line, we can go here to edit sketch. Let's go to annotation, and now we can define the dimensions. Here we can put 10. Here we can put, for example, 50. We can click OK, and we can exit sketch. And now we got this section view. Let's click OK. So let's go to section again. Let's go with vertical. Let's turn off auto start section. Let's click here. And now we can choose, for example, single offset like this. And now you can play with this and create something like this. You can also go with arc offset. Let's click OK. And let's go to the left side. And this is how you can create your own cutting lines. There is a second way how you can create a cutting line as well. And this is that first we create a sketch. So let's go to sketch, let's choose a line, and now we can draw a cutting line that we want. For example, we want something like this. This, and this. And OK. And now we can also put some dimensions if we want. Let's go notation, smart dimension. Let's put an angle here. 125 like this, and OK. Before we start using section view, we have to select all of those lines. So you click on the one line, hold Ctrl, and then select the rest of the lines. And now we go to view layout, section view, and we have our section view here that we got using our own defined cutting line. And those are all options how you can create a section view in the SolidWorks drawings. In this lecture, we're gonna show how to create auxiliary view. Auxiliary view is folded to an edge or an choosing line or sketch. So we can create auxiliary view from the existing edge or from a line that we sketch. For example, we want to create auxiliary view from this edge here, this one. So simply we go to view layout, here we have auxiliary view, and first we have to select a reference edge. And let's select this edge. Let's zoom out, and here we have our auxiliary view. And this is auxiliary view D. We can change name here. We can go to A. We can flip direction like this. We can also change display style as we like it. And we can change scale of this auxiliary view. We can go 1 to 5, 1 to 2, like this. And let's click OK. And this is how you can create a simple auxiliary view from existing edge. But as well, you can create your own line, your own sketch, and then use that line to create auxiliary view. So for example, let's go to sketch and let's choose line. Let's create a line here. And now we want that this line will be 60 degrees relative to this line here. But now as we see, as we shown in the previous lecture, view focus, that this line is not in the view focus of this view. So the one way is that we click on this line, Ctrl and X, then click on this view focus and Ctrl and V. Now we can move this line here, and now we extended our view focus. And now we can go to Smart Dimension, and we can put 60 degrees here. Like this, and OK. And now we can use this line to create auxiliary view. So let's go to view layout, auxiliary view, and let's select this line. And we have created auxiliary view, and this will be auxiliary view B. And OK. And this is how you can create auxiliary view using existing edge or using define sketch. In this lecture, we're going to show how to create a detail view. Detail view allows us to enlarge a part of a drawing view to clearly show small details. For example, we have this view here, and we want to put some dimensions. So we will go to annotation, model items, we can choose entire model and click OK. And now we have a mess here. If we make this a little bit more visible, we see that we have a circle here. Actually, we have two circles. And if we look from this position, this is not clearly visible. And we can see what are those dimensions about. In those cases, we use detail view because we want to enlarge this detail. In our case, we want to enlarge those two circles. So let's go back, undo. So let's go to view layout, detail view, And first we have to sketch a circle. With circle, we have to select the part of the body that we want to enlarge. So the center point of our circle will be here, since we want to enlarge those two circles. And now the size of the circle depends on us, what we want to enlarge. So something like this will be good. And here we have our detail, and you can position this where you want, somewhere here. And this is detail E with scale 1:1. Let's go to the left side. Here we have a style of our circle. So we can go with broken circle, like this. We can go with leader. Now if you drag E, you see that here is a leader. You can go with no leader, and you can go with connected. Now you see that those two are connected. Let's go standard. Here you can change a name of the detail. Let's go with detail A. And let's go down. Here we can also change display style. We can go shaded with edges. We can go shaded or anything that we want. And here we can change our scale. So we can choose custom scale, or we can define user-defined root. Since this is not some big enlargement here, I would like to enlarge this a little bit more. So I'm gonna go with 2:1, like this. And okay. And now you can go to annotation, smart dimension, and you can put dimensions here of those two circles. Okay. And now this is more visible and it's more clear. So instead of circle, we can have some other sketch. So let's show how to create some arbitrary spline instead of circle. Let's delete this detail. And before we start using the detail view tool, we have to create a sketch. So let's go to sketch and let's choose a spline. So let's draw a spline around here, like this. So now instead of a circle, we're gonna use a spline. Let's go to view layout and detail view. And now we have a spline. And those are two ways how you can create a detail view. In this lecture, we're gonna show how to create broken out section. With broken out section, we can expose inner detail of our model. So we have this model and we know what is inside because we created this model. But if someone is reading this circle, we want to know that that person will know that something is inside. And we want to show that. We can use section view as well, but if we don't need a cross section, then we can use broken out section. We can apply broken out section to isometric view and to the orthogonal view. So let's go to view layout, and here we have broken out section. When we click on broken out section, nothing happened at first. You don't notice anything. But if you move your mouse, you see the cursor has changed to spline. So first, you have to create a spline. So let's go here to our isometric view and let's create a spline, something like this. And now on the left side, we have to define depth. We have two ways how to define depth. We can use an existing edge, and then we have to use this dialog box, or we can go with numerical value. First, we're gonna show with numerical value. So instead of 10, let's go with 70. And here we can check preview, and now we can see the preview, and okay. And now the person who is reading our drawing knows that there is something inside. We can also apply broken out section to orthogonal view. So let's go to broken out section and let's create a spline here, like this. Okay. But now instead of numerical value, we're gonna use existing edge. So we're gonna choose this edge here, like this. We can click preview and okay. And now we see what is inside. So this is a really simple tool that can expose the inner details of our model. As well, we can edit broken out section. We can edit depth. So we can, instead of edge, we can use numerical value or vice versa. And we can edit our spline. So if we go to our tree on the left side, we have drawing view 1. And we see, this is this one. We see the highlighted rectangle. Let's click on this arrow, and here we have broken out section. Now we see our spline. Let's right click on it, and here we have two options. We can edit definition and we can edit sketch. Let's first edit definition. So instead of edge, we want to use numerical value. So right click here and delete. And now here we can put 60 and okay. And this is it. Now we want to change our spline. So let's go again here, right click and edit sketch. And now we can move our sketch here like this, like this, and okay. And we don't see changes now. So let's go here, rebuild, and now we see our changes. And this is how you can create broken out section. In this lecture, we're gonna show how to create a break view. Break view allows us to view a large part clearly in a smaller sized drawing sheet. So for example, we have this part and this is pretty big and it takes a lot of space on our drawing sheet. So we want to make it smaller. So we can create a break line here and here. And we can define the distance between two break lines, for instance 10 millimeters. And then those break lines designate that everything that is between those break lines is only a uniform continuation of the model. So let's show how this works. Let's go to view layout and let's choose break. First we have to select drawing view. Let's select this one. And now here we have few options. We can create a vertical break lines and horizontal. Here we can define the gap size. This is the distance between two break lines. And here we can choose break line style. We're going to show that later. So here now we have a break line. So first we have to choose position of the first break line. We can choose here. And now we have to choose position of the second break line. So we can choose here. And now, as you see, we have a smaller view. So everything that is between those two break lines, it's only uniform continuation. Here, we can define the gap size. Now we have 10 millimeters between those two break lines. We can go to 50, for example, like this. But we don't need this, so we're gonna go to 10 millimeters. We can also change break line style. We can go to straight cut. So we have something like this. We can go to curve cut. So we have something like this. We can go to small zigzag cut, like this. Let's go back to zigzag cut and let's click OK. Now as well, we can create horizontal break. Let's go to view layout, break, click on this view and let's choose here add horizontal break lines. So we can position the first break line here and the second here. And OK. And now instead of having a big view, we have a smaller view. And those break lines designate that this is only uniform continuation, everything that is between those two break lines. So if we want to dimension this view, we can go to annotation. smart dimension, and let's put dimension of this line here. And this is 355 millimeters. So break lines don't have effect on these plate dimensions. What it means, those dimensions are real dimensions that you define in a sketch. The same thing if we define dimension here. This is the real dimension. Doesn't matter that here is a break. This is not dimension of this view here. So keep that in mind. If we wanna delete or break, we can click here and press delete, and yes. This is how you can delete your break. Let's go back. If you wanna modify your break, just click on it, and here you can now choose the different gap size. Let's go to 15 millimeters, and you can choose the break line style. For example, we can go with straight cut, like this. As well, we can add a projected views. We can click on this view, and here we have projected view. So we can add projected view up, down, left, and right, and isometric view. Let's go with this top view, and we see that SolidWorks automatically create break views for projected views. And let's define left view and click OK. So we have break lines automatically added to our projected views. If we don't wanna break lines in our projected views, we can right click on it, and here we have on break view. And now we don't have a gap here. We still have our break lines, but we can click on them and delete them. But let's go back, undo, like this. Now we see that we can only move this view left and right. We can't position where we want. If we want to break alignment, we can right click on it. We can go to alignment and break alignment. And now we can position our view where we want. If we want to go back, we can right click on it, alignment, and default alignment. And OK. Also, let's click on the view. And here we have some options. We can change display style as we shown in previous lectures, and we can change scale. So we can go with 1:1, for example, like this, and we see that our projected views automatically changes according to our base view. And this is how you can create a break In this lecture, we're gonna show how to create alternate position view. Alternate position view is displaying a configuration of a model superimposed on another configuration of the model. So that means that alternate position view illustrates the range of movements within an assembly. For example, with alternate position view, we can show a different configuration of the assembly on the same drawing sheet. So we have this assembly, and this is one configuration. We can show here another configuration, and we have two options. We can show existing configuration, and we can create a new configuration. So let's show how this works. So let's go to view layout, and let's go to alternate position view. First, we have to select a drawing view. Let's select this one. And now we have here configuration. We can choose between new configuration and existing configuration. First, we're gonna go with existing configuration that I created previously. So let's choose here configuration C. And let's click OK. And now we see that this is configuration C. And now, for example, we have to measure the angle between this line and this line. And if we go to notation, smart dimension, we can click on this line and we can click on this line, and it doesn't work. So we have to create a two center lines. So let's go to sketch, center line, and let's create a first center line here, like this, and let's create another one here, like this. And let's go to Smart Dimension, and now we can measure angle here, like this. And OK. And this is how you can show two configurations, existing configurations, on the same drawing sheet in the same view. But now we're going to show how we can create a new configuration. So let's go to View Layout. Let's go to Alternate Position View. Let's click on this view, and here we have New Configuration. Let's click here, and let's call this configuration Configuration D. And let's click OK. And now we go directly to the assembly file. Here we can rotate this, and we can create a new configuration by rotating this. So now we're going to define a new configuration, but before we do so, let's turn on collision. So let's go here, Options, and Collision Detection on. And now let's rotate this part, and let's collide here. And let's click OK. And now we have a new configuration A here. And now we show with one drawing view 3 different configurations of the assembly. And this is how you can use alternate position view. In this lecture, we're going to show how to create crop view. Crop view crops existing view to show only a portion of the view. For example, we have this view and we don't want to show the whole view. We want to only show the portion of this view. For example, this portion of this view. So we can go to View Layout, and we have Crop View here. So let's select Crop View. So we got a message here that first we have to create a closed sketch profile. So let's go to Sketch. So we can use or circle or spline. Let's go with spline. And let's define a sketch here like this. And now we can go to View Layout, Crop View, and we gotta crop off an existing view. And now we can have this view, and we can insert front view here. Okay, we can go to change scale like this. And now we have a front view, and we have a crop view of this front view. In this lecture, we're going to show how to create isometric section view. To create isometric section view, first we have to create a standard section view that we shown in this section. So we have this view, and we want to make a section here. So we have to go to View Layout and choose Section View. So we're going to go with standard cutting line, vertical, and let's check Auto Start Section View. So now we can position where we want to make a section. So we're going to make a section here, and now we can drag this to the left or the right. And we can leave this here. Now we have a normal standard section view, section BB. Let's click OK. And now if we want to make isometric section view, we can just right click on it. And here we have isometric section view, and just click here. And now we got isometric section view. You can also change the name. Here you can flip direction like this. You can go with something like this, and you can change display style. We can go like this, and you can change scale. Let's go 1:1, and OK. And now if we move this, we see that we can position this where we want. We have to break alignment. So we can just simply right click on it, alignment and break alignment. And now we can position this isometric section view where we want. For instance, here. Okay, we can move this here, and okay. And this is how you can create isometric section view. In this lecture, we're gonna show how to create bill of material table or BOM. Bill of material table is table that includes all the materials, parts, and sub-assemblies required to build a specific assembly or a product. So we have a disassembly here, and for this assembly, we wanna create bill of material tables just to see how many parts we have, how many sub-assemblies we have, what is the quantity of those, what are materials of those, who designed those parts, and so on. Depends what we need or want. So if we want to create bill of material table, we can simply go to Annotation tab, and here we have tables. Let's click here and let's choose bill of materials like this. And now first we have to select a drawing view to specify the model for creating a bill of materials, and we're gonna specify this view. And now we have some options here. For the first time, we're gonna leave options as they are, and let's click OK. Now just move your mouse to the drawing sheet, and now you can position your table where you want. Let's go here, like this. Now if we look at our table, we see that we have item number. We have assembly 1, assembly 2, and a sub-assembly. Those assembly 1, assembly 2 are parts. Their names are just assembly. So we have quantity 1, 1, and 1. If we want to adjust our table, we can click here, and we can just adjust our table how we want. So let's do something like this. And now let's click here on the left top, like this. And let's see what kind of options do we have. We have here BOM type. We have top level only, we have parts only, and we have indented. Top level only shows all the first level parts and sub-assemblies. Now as we see, we have a parts and sub-assembly. It doesn't show the parts within sub-assembly, so we don't see parts in this sub-assembly. If we go to parts only, this shows the list of the individual parts without indicating sub-assemblies. So we don't have a sub-assemblies, we only have parts. 1, 2, 3, 4, and 1, 2. And the indented shows the first level parts, 1, 2, and sub-assembly, and parts listed within sub-assemblies. So we have parts 1, 2, 3, 4 in the sub-assembly. If we click here, we have no numbering. Now as you see, our sub-assemblies don't have numbers. We can click here and we can go with detailed numbering. Now we have 3.1, 3.2, 3.3, 3.4. Those parts are part of the sub-assembly. We can also go to flat numbering. Now we have a 1, 2, 3, 4, 5, 6, 7. So really depends how you want. Let's click OK. And this is how you can create a simple bill of material table. Now for example, if we want to see those parts, part 1, 2, 3, 4, 5, 6, 7, here which part is which, we can click on this view, go to Annotation tab, and here we have one tool, Auto Balloon. Let's click on this. And OK. And now we see that we got designation of every part. This is part 1, 5, 4, 6, 2, and this one is 7. Let's click here. With this simple bill of material table, we show all parts and all sub-assemblies with their quantities. and we show on the 3D assembly which part is which. In this lecture, we're gonna show how we can sort bill of material table by any properties that we want. So we have bill of material table here. We have item numbers. We have part numbers, those are our names. And we have part number here and quantities. So we have a parts and sub-assemblies. And now we want to sort our bill of material table by part number, and we can go in ascending order so that the lowest number will be here and the biggest here, or we can go by descending order so the biggest will be here and the lowest here. For example, you can have a column here, price, and then you can sort your table by price. So you can start with the most expensive one or the cheapest one, depends what you want. So we have some numbers here, part numbers 629475, and we want to sort this part number column in descending order. To do that, we have to click here, and now we see that this column is designated, and we can just simply right click here and choose sort. We have this dialog box, and here we can sort by. We have the first layer of sort, we have second layer and the third layer. We're gonna only use the first one, and here we can choose. We can go by item number, part number, quantity, and so on. Here we can choose, we can go in descending order and ascending order. We're gonna choose sort by part number and in descending order, like this. And here at the bottom, we have item numbers. Those are our item numbers. So we can choose here, do not change item numbers. We won't check this now. We're gonna show this later. And let's click OK. And now we see that the biggest part number we have here, and we have the lowest here. So we have 9, 7, 6, 5, 4, and 2. And this is how you can sort your bill of material table. Now we're gonna show how we can order our item numbers. Let's click above this table here, and here we have some options. Here we have item numbers. We can start our item numbers by 1. As we see here, we have 1, 2, 3, 4, 5, 6, and we can have increment by 1. And we have that here, 1, 2, 3, 4, 5, and 6. But we can start our item numbers at 5, for example, and now we have 5, 6, 7, 8, 9, 10. And we can change increment, for example, to 3, and now we have 5, 8, 11, 14, 17, 20. Let's go back to 1 and 1, like this. And here we have follow assembly order. What that means, when you create an assembly, you start with part 1, then you got part 2, part 3, part 4, and so on. And if you want to see this order here, we can click this follow assembly order, like this, and now we see assembly 1, assembly 2, sub-assembly 1, 2, 3, and 4. Here down we have do not change item numbers. What that means? That means that we can sort our bill of material table by, for example, part number in ascending order, and now if our assembly 1 with part number will be in the 4th position, here at item numbers it won't be designated 4, it will be designated with 1. So let's check this. Let's uncheck follow assembly order and let's click OK. Let's click here part number. Let's go to sort. And now let's sort by part number in ascending order and click OK. And now we see that assembly 1 always has item number 1, assembly 2 has item number 2, sub-assembly 3, 4, 5, and 6. So item numbers didn't change. And this is how you can sort bill of material table and how you can work with item numbers. In this lecture, we're gonna show how we can find the missing item in the bill of material table and how we can exclude the item from the bill of material table. So let's look at our table. We have assembly 1, assembly 2, subassembly 1, subassembly 2, and subassembly 4. Here we see that subassembly 3 is missing. If we look at our assembly, we have here 1, 2, 3, 4, 5, and here we have asterisks. So this component is missing from bill of material table. And why would someone hide the component from bill of material table? Maybe the part is not important enough to list, or it's too confidential for anyone to see. To show this part, to find this part, we can simply click on this assembly, go here on the feature manager design tree. Let's open this and let's extend this to see our tree. Now if we look at our tree, we can find here excluded from BOM. And now we know that this part is excluded from BOM. We can just simply right click on it and click here, include in BOM. Let's see. And now we have the part 6. This is subassembly 3 and we have 6 here. And this is how you can find your part that is missing. If you want to exclude some part from bill of material table, you can just simply click here on the assembly and open assembly. And we want to exclude this yellow part. Let's first click on this part and let's find this part in our tree. We see this is assembly 2. Let's click on this assembly and here we have component properties. Let's choose this one. Let's go down and here we have exclude from bill of materials. If we check this and click OK, then this part is excluded from bill of material table. We can go back to our drawing and we see now that this part has asterisks and this part, assembly 2, is excluded from bill of material table. And this is how you can find missing item or how you can exclude part from bill of material table. In this lecture, we're gonna show how you can change the name of the column, how we can change the column information, and how we can add a new column and how we can add a new row. So we have this bill of material table and we have here item numbers, we have part numbers and quantity. And here we have names. Here we have written part number. And instead of part number, we wanna write here name. So simply just double click here and now you can write a name like this. And if you want to confirm this, just click outside of the bill of material table on the drawing sheet here. And now you change the name of the column. If you want to change the information of the column, for instance, here we have part number. And instead of part number in this column, we want to show the costs of every part. To change that, we can click here and then choose column property like this, or we can just double click here and now we have column property here. Here we have two options. First, we have a column type. We can go with custom property, but we can change this. We can go to equation, we can go to unit of measure, and so on. So let's go to custom property, and here we have a property name. Now we have a cost. We can go to part number like it was before, but we wanna choose cost. So let's choose cost, and now let's click outside of the table here, And now instead of part numbers, in this column we have costs. Let's adjust our table a little bit like this. And now here we want to add a new column. In this column we'll show part number. To add a column, you just click here, right click and insert. And now you have two options here. You can add a column to the right side of this column, quantity, or you can add a column to the left side of this column. Let's add a column to the left side like this. And now we can choose here custom property, and let's choose for property name part number. You can also choose who's the author, what is the title, the file name, and so on. Depends what you wanna show in your bill of material table. Let's go with part number and let's click here. And now we added a new column. If you wanna delete your column, you can just pick your column, for instance, cost, right click, and here you have delete, and you can delete the whole table or just the column. And we want to delete just column like this, and now we don't have costs. And now we're gonna show how to add a row. To add a row, we can just click here, right click and insert. And now we can insert row above and row below. Let's insert row below like this. Let's click here, and now you can write here what you want. If you want to merge your cells, for instance, we want to merge those two cells, we can click here and drag your mouse here. And now we have designated those two cells, and right click on it. And here we have merge cells. And now we can merge those two cells. And this is how you can work with custom properties in the bill of material table. In this lecture, we're gonna show how we can use equations in bill of material table. Equations allow us to do simple calculations and simple functions. So with equations, we can multiply, subtract, or add different properties. As well, for example, we can find what is the overall cost of the assembly, what is the most expensive part, or something like this. So we have this assembly. We have three parts, part 1, part 2, and part 3. The part 1 has 2 pieces, part 2 1 piece, and part 3 4 pieces. Our task in this lecture will be to find what is the overall cost of this assembly and which part is the most expensive. To do that, first we have to add a column here with costs. So we must know what is the cost of each part. So let's do this. Let's click here. Let's right click, insert, column to the right. Let's go with custom property, property name, cost, and click here. And now we know what is the cost of each part. In the second step, we want to multiply quantity with cost. So we have to use equations. But before we do so, we have to add a new column that will be called part cost. So let's click here, right click, insert, column to the right, and let's click here. Let's double click here in this cell, and let's type in part cost, and this is it. And now if you want to add equation that will multiply quantity with cost, and the results will be shown here, we have to designate this column like this, and here we have a symbol of equation. Let's click on this equation. So what we have here? We have here some functions, and now it's only available if. So this doesn't help us. So how we can make equation? We can first go to columns and we can choose what we want to multiply. We want to multiply quantity. Let's choose quantity. And now let's add asterisk. And we want to multiply quantity with cost. Let's go to column and cost. So we have quantity multiplied by cost. And okay. And now we have here 5 multiplied by 5.2 is 10.4. And here are our results. In the next step, we want to find which part is the most expensive one. We know this is 17.6 because we see here we only have 3 parts. But if you have, I don't know, 50 parts, you don't want to look individually which is the most expensive one. You can add a row here and then use function. So let's add a row, right click, insert, and let's add a row below. Click here, and we want to show our results in this cell. So let's click here. Let's go to equations again. And here we have functions. Let's open our function and let's see what we got here. We have a if, average, count, max, min, sum, total. So we're gonna use max. What is the max cost? Let's click here. And now we have to designate our costs. So let's click on this cell and let's drag down like this. Now we have F2 to F4 and okay. Click here and we see that the most expensive one is 17.6. Now let's show how we can add those 3 costs. Let's add a new row and let's find what is the total cost of this assembly. So let's click here, right click, insert, row below. Click here and let's write here total cost. Let's merge those 3 cells like this and merge cells. Click here, double click, continue editing the cell, yes, total cost, and okay. And we want to show our total cost here. Let's click here. Let's go to equation. And now we're going to use function. We can use sum or total. Let's show how total works. Let's click on the total and let's click OK. And now we see that our total cost is 34.5. Let's double click this. Let's delete. And click here. Let's again click in this cell. And let's try to use a sum. But now we have to designate which numbers we want to add. We want to add those 3 and okay. And we got the same result. So it's up to you which function you're going to use. And this is how you can use equations in the bill of material table. In this lecture, we're going to show how we can show and hide component on the drawing sheet. So we have this assembly, and here we see that some parts are missing. So how we can show those parts or components? We can click on this drawing view. Let's go to our design tree. We see this is drawing view 1. Let's open this. Let's open our assembly. And let's open our sub-assembly. Let's extend this. And here we see that sub-assembly 1 and sub-assembly 3 are hidden. If we right click here on the sub-assembly 1, we can go to show height. But only option that we have here is height. If we go to sub-assembly 3, if we go to show height, also we only have height. And if we go to subassembly 2, this part, let's right click on it. Let's hide this component. Now this component is hidden. And let's show this component. Let's show hide and show. Now why is this the case? That some components we can show here, but some components we can't. Because those components that we can't have symbol here, this one, special symbol. And that means that those components are hidden in assembly. And those components that we hide here, they're only hidden from drawing. So to show those components that are hidden from assembly, we have to go to assembly. So let's click on our drawing view and let's open assembly. Now we have assembly here. Let's go to our feature manager design tree. Let's extend this. And here we have subassembly 1. We see this is this component, and subassembly 3. This is this component, this pin. And here we have a tool, show hidden components. Let's click on this. And now we can see which components are hidden. This one and this one. Let's exit show hidden. And now, just to show those components, we can just right click here on the subassembly 1 and here show components. And right click on subassembly 3 and show components. And now both components are shown. But before we go to our drawing sheet, make sure you rebuild. Like this. And now let's go to our drawing sheet. And now we see our components here. So simply, if we go here to subassembly 1 and hide in the drawing file, we can also show in the drawing file. But if components are hidden in assembly, you can't show them in drawing. You have to go to assembly. In this lecture, we're going to show how to use linked nodes. We can link displayed nodes to a previously defined custom property or to website. For example, we have to find who is the author of this component, this one. To accomplish that, we can use linked nodes or we can use bill of materials table. We're going to show both ways. But first, we have to go to annotation and to node. And let's click on this component here. And now on the left side, we have some options here. Insert hyperlink. Let's click on this. So we can insert a link here of some specific website. And then anyone who would press on this link would directly go to that website. So you can link to website and let's cancel. Here we can link to property, and this is what we're looking for. Let's click here, and now we have some options here. So we have here use custom properties from. We're gonna choose model found here, and here we're gonna choose component to which the notation is attached. This. And now under property name, we want to find who is the author, so we're gonna choose here author. And now we see here evaluated value Mike Watson. Let's click OK. Let's click OK here. And now we see that Mike Watson is author of this component. Let's drag this to site. And this is one way how you can find some specific property of component. The other way is to create a bill of material table. So let's go to annotation tab. And let's create bill of materials. And let's click OK here. Let's place our table here. Let's adjust our table. So to find who is the author, we have to add a new column with property author. So let's click here, right click, and let's insert column on the right. And for a custom property, we're gonna choose outer. Let's click here. And now we don't see the result, Mike Watson. And this is because we use a BOM type top level only. Let's click here and let's change BOM type to parts only or to indented. Let's go to parts only, or you can choose indented, the same thing, and OK. And now we see that for the subassembly, the outer is Mike Watson. And this is how you can use linked nodes and how you can find specific property of some components. In this task, we have to insert a front view of the part Q1 part, then create a dimension X and measure this dimension. So we have to open this drawing and then we have to insert this front view and measure this X angle. Let's go to our drawing sheet. So we have something like this. Now let's go to view layout, to model view, and we have Q1 part. Let's open it and let's go with front view. And let's click preview. And now we see that this is not what we are looking for. This is not the front view that we need to create. So now we have to define a new front view. Let's open our part. Q1. And now let's go to our question. And we must have something like this. We are looking for this face. So let's click on this face, hold Ctrl and this face. This will be up. So let's go to normal 2 and let's go to more options. And here we have update standard views. Let's click on it and let's click on the front view. And we want to make this change. Yes. Let's go to our sheet. And now if we go to view layout, model view, view part 1, front view, and this is the view that we're looking for. And now if we want to measure angle between this edge and this line, it's not possible because this line, it's not in the view focus of this front view. So we have to click on this line, Control X, click on this view focus and Control V. And now we can see that this line is in the view focus of this front view. Now we can go to annotation, smart dimension, click on this edge, and we have 7.49 degrees. If we check our result, we have 7.49 degrees. And this is the correct answer. In our second task, we have to make a projected view from the front view, and then we have to measure this Y angle. So let's use our previous drawing from the question 1 and just click on this view. Now let's go to view layout and we have here projected view. And we have something like this. That's okay. We can click on it and we can change display style. Okay, let's drag it down. And now let's go to annotation, smart dimension, and we have to measure the angle between this edge and this edge. And this is 30 degrees. Now let's check the result. And the answer is 30 degrees. In this task, we have to create a section view, AA, as it's shown here, and then we have to measure this area. So let's go to our drawing sheet, and we have two options how we can create a section view. We can go directly to the section view icon, or we can first create a sketch. Let's first create a sketch. So it's got something like this. Now let's make this one horizontal. And let's go to annotation, smart dimension, and we have 15 and 32. So we have this, and this is 15. And we have this one, and this one actually 33. Like this. And now we just select our lines. Just click on the first one, hold Ctrl, and then select other lines. And now let's go to View Layout, Section View. And now you have a question: do you want to create a legacy foreshortened view or a standard section view? Let's create a standard section view. Let's go up and let's put him here. And this is our section AA. Now let's go to Evaluate and let's choose Measure. And let's click on this area here. And we have 5412.29. Let's check the result. And this is 5412.29. And this is the correct answer. In the next task, we have to open our assembly, insert the isometric view, and then create a bill of material with the top level only, configuration default, part configuration grouping, display as one item number, display all configurations of the same part as one item, start at 1 increment of 1, all item numbers change when reawarding rows. First column should be item number, second column part number, third column description, and the fourth quantity. And we have to find the quantity of disk in the assembly and select it from the choices given. So this is what we have to create. So let's go to our drawing sheet and let's go to View Layout, Model View, and let's click on our assembly and let's go with isometric. Like this. Let's change the display style, and this is it. Now let's go to annotation, tables, and bill of material. So first we have to go with top level only, then configuration default, display as one item number, this is okay, display all configuration of the same part as one item, this is also okay. Then we have start at 1 increment by 1, this is also okay. And here we have do not change item numbers, so we won't check this, we will leave it unchecked. And let's click OK. And this is our bill of material table. And the question is, we have to find the quantity of disk, and this is 2. So the question is find the quantity of disk, and the answer is A2, and this is the correct answer. In our next task, we have to use the bill of material table that we have created, and then we have to modify the bill of material so that it's sorted by part number in the descending order. And then we have to find the item number that corresponds to the assembly component identified by X. So let's go to our SolidWorks drawing sheet. Now we have to sort this column by part number in the descending order. So let's click here, right click, let's go to sort by part number but in descending order, and let's click OK. And now we have to find, let's click on this part, and we see this is the disk and the item number of the disk is 1. Let's check results, and the answer is 1. In this task, we have to add a column named total cost multiplied by the quantity of the corresponding component, and then we have to calculate the total cost of all of the components here. Let's go to our drawing sheet. And now first we have to add a column. Let's click here, right click, and insert column right. So we won't use a column type custom property. Let's click here, and now let's just click here once, and here we have equation. Let's go to equation. So from functions we only have if, so we won't use it. Let's go to custom properties. Now let's choose cost here, multiply by quantity, and click OK. And now we have to add a row. Let's click here, right click, let's insert a row below, and let's just click here, and let's go to equation. And now we're going to use a functions, so we're going to use a total, and click OK. And the total cost is 39.82. Let's see the result. 39.82, and this is the correct answer. So the first question is that we have to measure the angle between this line and this line on the front view. So we have to insert our front view, and then we have to measure what is the X angle. So let's go to SolidWorks, and we have opened this drawing, and now we have to insert our part. Let's go to View Layout, Model View, Browse. Let's find our part. And now if we want to insert front view, let's turn on preview. We see that this is not what we're looking for. This is not the right front view. So we have to adjust front view. Let's click escape. Let's open this part. Open. No. And let's look at our part. So we must have this view. This must be front view. So if we look at it, we're looking for this face, and hold Ctrl and click on this face. Now let's go to normal 2, and now we can just easily go to more options, and here we have update standard views. Just click here and front view, and yes, and this is it. Let's go to our drawing sheet. Let's go to model view and with front view, and now we see that our front view is in the good position. Now if we want to measure the angle between this line and this line, it's not possible because this line is not in the view focus of this front view. As you see, view focus with dashed line. So we have to click on this line, hold Ctrl and X, and click on this view focus, Ctrl and V. Okay, and now our line is in the view focus, as we see. And now we can go to annotation, smart dimension, click on this line, and we have an angle 20.85 degrees. And now if we check our result, be 20.85 degrees. And our first question is complete. So let's look on the second task. The second task, we have to measure the angle Y. So we have to create this projected view from front view that we have created in the previous task. So we have unit system the same, decimal places the same, and we have to create a projected view. So let's go to our drawing sheet. Okay, now we have to create a projected view from the front view. Just click on the front view. Let's go to view layout, and here we have projected view. And now we have to go to this side, something like this. Let's drag him down a little bit. Let's see what is the angle. So it's between this edge and this edge here. So let's go to annotation, smart dimension. Let's choose this edge and this edge. And this is 22.01. Let's see if this is correct answer. So we go down 22.01 degrees. And this is correct answer. In the third question, in the third task, we have to create a section FF and then measure the area of this section here. So we have the same unit system, decimal places, all the same. So let's go to our drawing sheet. So we have two options how we can create section view. We can jump to the section view and start with this icon, or we can first create a sketch. Let's first create a sketch. So let's start from here to this point, here, here to this point, and here. Now let's make this one horizontal, and let's make this one horizontal. And I think those ones are okay. Horizontal, vertical, horizontal, that's okay. So we must have here 10 millimeters. Let's go to smart dimension and let's click on this one and this one, and let's make it 10. And now let's click on this line, hold Ctrl and select all lines. Now let's go to view layout and section view. And now, do you want to create a legacy foreshortened view or a standard section view? Let's create a standard section view. Let's go up, and now we can flip direction, and that's it. And now just let's go to evaluate, measure, and just click on this area here. And this is 924.12. If we look at the results, we have 924.12, and this is correct answer. In the next task, we have to create a bill of material table. So we have to insert the isometric view of the default configuration of assembly. Then we have to create a bill of material with top level only, configurations, default, part configuration grouping, display as one item number, display all configuration of the same part as one item. Item number start at 1, increment 1, allow item numbers to change when reordering rows. First column should be item number, second part number, third description, and the fourth quantity. So let's go to our sample drawing sheet and let's insert our model. Let's go to view layout, model view. Let's go to assembly and let's filter assemblies. Let's go with launcher, build, and let's go with isometric view like this. And let's make it in the color. That's okay. And now let's go to annotation, tables, bill of material. So we have top level only, configurations default, display as one item number, and then we have display all configurations of the same part as one item. This is good. We have start 1, increment 1, and here do not change item numbers. We want to leave this unchecked. Let's click OK. Let's put it here, our table. So we have item number, first column. The second number should be part number. So let's double click here. So column type, let's go with custom property, and the property name, let's go with part number. This is okay. We have description and quantity. So the question is find the quantity of sub trigger assembly. So if we look on the sub trigger assembly, the quantity is 2. So if we look at answers, so we have the fourth question is 2. So the next question, we have to use the previous bill of material that we have created. So we have to modify the bill of material that is sorted by part number in ascending order. And then we have to find the item number that corresponds to the assembly component identified by X. This one. Let's go to our SolidWorks. So we have to sort our part number in ascending order. So let's click here. Right click, let's go to sort. We have part number, ascending order, that's okay. Click OK, that's it. And now if we click on this part, not an edge, we can see that this is launcher main body, item number 1. So if we go to our answers, we can see item number 1 is correct answer. So in the next task, we have to calculate the total costs of all parts. So we have to add a new column and a new row. Let's go to our previous created bill of material. Let's just click on this last column, right click, and let's go with insert column right. So we don't want to add any column type. Let's just click here, and here we have an equation. Let's click on the equation. We don't have any functions, only if. So let's go to custom properties. So we want to multiply costs with, we go to columns, with quantity, default quantity, and let's click OK. So we have results here. And now let's click on the last row, right click, let's insert row below. Let's click on this 0 equation, and now we're going to use functions, and we're going to use total, and OK. So we got result 33.64. Let's see if this is correct answer. 33.64, and this is the correct answer.